All right, so when we talk about numbers, we want to classify numbers. We want to figure out what kind of numbers are what, because we have different kinds of numbers that exist. When we first started learning about numbers, we learned about things like 1, 2, 3. Great, that was easy. Then we started talking about things like 1/2, 1/4, 1/8. Okay, it gets a little more complicated. Then we started talking about things like 0.25, 8.9, 12.17. Okay, we don't love decimals. That gets into a little bit of decimals. Then we started talking about things like -7, -1/5, -25.8. We started talking about negative numbers, and that's a whole nother category of numbers. And then sometimes we even have this number that throws us around a little bit and isn't exactly the same as what we think it is, but it's a 0, and then there's that. And then we have pi, and we have square root of 17, and we have all sorts of numbers that exist. And all the numbers that exist that we're dealing with, these are called real numbers. We're not even going to be talking about imaginary numbers today. Today we're just going to be focusing on real numbers. And so when we talk about real numbers, what we want to do is we want to make this chart. And on this chart, we want to split our real numbers up into rational numbers and irrational numbers. Rational numbers and irrational numbers. So within all of real numbers, there are some numbers that are rational and there are some numbers that are irrational. We're going to talk about how to know which is which. So, a rational number, every rational number can be written as a fraction. If you can write it as a fraction, a over b, or whatever you want your fraction to be, that makes it rational. So it's any number that can be written as a fraction. It can also be a terminating decimal or a repeating decimal. So if it's a decimal number, decimal numbers are rational as long as they stop or they end up repeating forever and ever and ever. Okay, so rational numbers are going to be things like 24/7 or 0.777 repeated, or 1/8 or 14.25, things like that. These are all rational numbers. They end. They have a stopping point. Now the difference with that, irrational numbers are numbers that don't end. They go forever and never stop. The most common example of that is pi. Pi goes on forever. It doesn't end. It doesn't repeat. Pi is an irrational number. Other times we see irrational numbers, or when we have things like non-perfect square roots. Non-perfect square roots, like the square root of 11, is irrational. There's no ending to that answer. It goes on forever and ever and ever. So this would be an irrational number, or the negative square root of 71, or the square root of 2. Things like that would be irrational. Rational goes on forever and ever. Rational stops. Okay, now, within rational and irrational numbers, there's a category within rational numbers, which is our next category here, and this is called integers. Now, all of our integers are going to be rational numbers. So the further we get in, the smaller we're going to build this in this box. And the more we go in, it's all the things outside of it. Okay, so if it's an integer, it's also rational. Okay, so integers are going to be the negative numbers, right? We saw this with -3, -1, -14, -25. Integers are going to be our negative numbers. When we talk about negatives, those are integers. All right, now our next box, we got another box here. Our next box here is going to be what we call whole numbers. And then within whole numbers, we're going to add our next box, our last box. But I wanted to get whole numbers in there so that we can talk about the difference in these last two boxes. So we have whole numbers, and then here we have natural numbers. Okay, so natural numbers are numbers we count with. When we count, we talk about our natural numbers. 1, 2, 3, 10, 18. Like when we're counting, just starting counting, those are natural numbers. Think about the first numbers you learned. Those are the natural numbers. And the difference in natural numbers and whole numbers are 0. 0 is not a natural number. When we start counting, we don't start with 0. We don't start 0, 1, 2, 3. We don't do that. But 0 is a whole number. It's not a natural number. Okay, so there's the difference there. So here's our chart that we want to be working with today. Now, let's say I have the number, the negative square root of 4. And I want to classify this number. Well, before I classify, I want to simplify as much as I can. The square root of 4 is 2, and the negative of 2 is -2. And so now -2, I look and I say, well, -2 falls into integers. It's a negative number. So this is an integer. And because it's an integer, I know it's also rational. So -2, or the negative of the square root of 4, is an integer and a rational number. It's both of those things. Okay, so if it's in a small square, it's also in all the bigger squares outside of it. So if something's natural, it's natural, whole, integer, and rational. If something's just rational, it's just rational. Okay, if I have -3/8, that's a fraction. That's just rational. I can't simplify it any further. So this is just rational. Okay? Classify some of these. Talk about it tomorrow. Have a great night.